Okay, hello lads. So we're going to have to look today at the general functions for trig. Okay, so this is quite a popular question. It comes up quite often. So I'm going to show you a couple of examples. So I'm going to find the general function of when the cos of theta is equal to minus root 3 over 2. Okay, so, and I'm going to do it in radians. Okay, so let's figure it out. So first of all, let's rearrange this. So let's get the cos away from the theta. Now, that minus doesn't mean get the minus. That minus indicates where we're going to look for the reference angle. So let's work out our reference angle. Our reference angle for cos of root 3 over 2, cos inverse root 3 over 2, the reference angle we're looking for is pi over 6. So where is cos negative? It's negative in the second quadrant, and in, I think it's, remember, the third quadrant. So let's find the two angles we're actually looking for. So theta could be pi over 6 take away pi, or it could be pi over 6 plus pi. So there's our two possibilities. So use your calculator on that. That's going to give you 5 pi over 6, and that's going to give you 7 pi over 6. And always try and get it down to a nice neat fraction. So now there's our two angles it could be. So let's see what our general solution would be. So theta could actually be this number plus, and this is the important thing in radians, all you have to do is write 2n pi, or 7 pi over 6 plus 2n pi, where n is an integer. Okay? So that's your general formula. So when you pop in an integer there, you get a version of that works. Okay? Now, you won't get one that's just cos. You're going to get one that's something a little bit else. So I'm going to show you some examples of that. Now, I will do these in radians, but I'll also do them in degrees just to show you it works. So let's say you have the sine of 3 times theta, and it's equal to a half. And I'm going to do this in radians. So let's peel back the layers here. First of all, let's remove the sine. So 3 times an angle is equal to the sine inverse of a half. That's positive, so I can just look straight for where the sine of a half, what am I going to get? And of course I'm going to get pi over 6. So that's pi over 6. So I'm just going to write that here. So let's do our quick sketch. So where is sine positive? First and second. So theta, 3 theta, could be pi over 6, or 3 theta could be, in the second quadrant, it's going to be pi minus pi over 6. Now, we're going to get our general formulas first of all. So 3 theta could be pi over 6 plus 2n pi, or 3 theta could be, let's work this one out, 5 pi over 6 plus 2n pi. Now let's work out theta. So we're going to divide across by 3. So when I divide pi over 6 by 3, so I just use my calculator because I want to be sure I'm right here. Pi over 6 divided by 3 is pi over 18. Okay, so that's really pi over 18 plus 2n pi over 3, or theta is equal to, right, let's work this one out, 5 pi over 6 divided by 3, which is 5 pi over 18, plus 2n pi over 3. for any value of n. So there is my normal general equation for this. Now, if I want a specific amount of angles, if I actually want to generate an angle, that's where I have to do something slightly different. So I'll show you that on the next one. Okay, and this time I'll use degrees. So this time I'm going to get the cosine of 2 theta is equal to minus a half, and we're going to do this in degrees. But this time we don't just want the general formula, we want all the possible answers. So for theta is less than or equal to 360 and greater than or equal to 0. So we're going to get all the possible answers for this. So I'm going to do it virtually the same way here I set on doing it in degrees, except when I get down to here, I'm actually going to find answers to it. So first things first, let's remove the cos. So 2 theta is equal to the cos inverse of minus a half. So remember that minus just tells us where to look. So let's do our quick. Whereas cos negative here, and cos is negative here. So that's where I have to look. So let's see what the cos of a half is. So cos of a half is 60. So we're going to do 60 degrees is my reference angle. So I need to find what 60 degrees in here. It's going to be 180 minus 60, which is 180 minus 60. Let's go. So 2 theta is going to be 180 minus 60, or 2 theta is going to be 180 plus 60. So let's write them out. 2 theta is going to be 120 degrees plus, now here we wrote 2n pi, here we just write 360n. It's the same thing, just in degrees. Same thing here, 2 theta is equal to 240 degrees plus 360n. Now, same as before, what's the next step? It's to get theta. So theta is equal to divide everything by 2. That's 60 degrees plus 180n. And this theta is equal to 120 degrees plus 180n. Now, how do I get my answers? Well, we're going to have to substitute in a value for n. So we start with n equals 0. And let's see what happens. That will make theta equal to 60 plus 180 times 0, which is 60. So that's okay. That's within this realm. Let's try it for 1. If I put 1 in there, that's 60 plus 180 times 1. That gives me 240. That works. Something tells me if I try 2, it won't work. If I put 2 in there, that would give me a theta of 60 plus 180 times 2. 180 times 2 is 360. 360 and 60 is 420. And that doesn't work because it's outside. So now let's check here. If n equals 0, then theta equals, that's 0, so theta is equal to 120 degrees. If n equals 1, then theta is equal to 300 degrees. And if n equals 2, well, you can guess what's going to happen. Theta is going to be equal to 360, 460, 480 degrees, and that's too far. So I have 1, 2, 3, 4 possible numbers that it could be. And there's your trick. The number of actual solutions will be a multiple of 2. So in other words, 2 times 3, if I was to do this out, I'd get 6 possible answers between 0 and 2 pi. When it's 2, I'm going to get 4 possible answers. When it's 1, I get 2 possible answers. And that's the way to do it.